So, Jim, we'll go to data stream.
Okay.
We'll go look at for the front O2 sensor.
Okay.
We'll select it and put that item up as a single item to watch by itself.
Absolutely. With single data stream, we're looking at a higher resolution, so we should get a pretty good idea of what's going on with this O2 sensor. And remember, once again, this O2 sensor, what we're looking for here is we're not looking for voltage. Everybody's used to testing O2 sensors with voltage, all right? Voltage is for 4-wire sensors for the older style sensors. Voltage is very important. You can't forget to test voltage. However, on a wideband sensor, you're actually more accurately looking at that sensor by looking at the milliamperage signal that actually forces the Nernst cell back to stoichiometric. That's what the computer uses to determine its rich or lean condition. That response time, or the response time of that O2 sensor switching, if you watch that milliamperage signal, you can actually determine rich, lean, and the response rate of that sensor. So Steve, go ahead and pull us up. Let's graph it and let's see what kind of information we can pull up on this thing. We're going to bring our speed up. We want to have the speed at a high rate of speed. We want this to get the O2 sensor up to a proper operating temperature so it's got the best chance of responding. And now we want to look at that value. Let's go ahead and back to the screen. And if you start looking at this, we've got some spikes on that O2 sensor. But look at the change rate. As we move forward here, you can clearly see that this O2 sensor is all over the place as far as response rate. With an O2 sensor that's responding erratically like this is a key component of diagnosis. If the O2 sensor responds erratically, we can run into a situation where it's not going to be allowed to test, or it won't do the testing properly. Now, the situation that we have here is we've run the sensor starts off very, very slow. And as we change the speed and keep the speed up, as it heats up and begins to burn off, the response rate starts to come back closer to normal. But notice once again, the response rate is constantly changing on this O2 sensor, all right? What we're looking at here is we're looking at an O2 sensor that's very likely going to be in a compromised condition, very likely going to be carbon fouled or fuel fouled. In this situation, this O2 sensor is going to be a potential problem. So right now, we've got enough information that we've put together to state that we need to replace this front O2 sensor to get this car operational. Now, the key thing to remember here is we've diagnosed a problem that we weren't necessarily expecting to find. Remember, when we started off here, we were looking at a catalytic converter code. But as we said, you have to look at a catalytic converter code in context with what else is going on the car. You never want to replace a catalytic converter until you make a determination as to what's going on. All right, Steve, that's good. Let's go ahead and bring it back down to idle. Now, I just want to point out to you guys, when we're looking at that graphing, okay, be really sure that you pay attention to the actual scale here. Because if you don't, you can actually get yourself in a little bit of trouble. It looks like there's a lot of movement on that graph, okay? But if you look at the scale, you'll see the range that we're talking about is plus or minus 150 milliamp. Okay? At plus or minus 150 milliamp, even though it looks like a lot of movement, that for all intents and purposes is running darn near flat line. Okay, based on what we have seen and what we have tested, it's looking like we're going to have a faulty front O2 sensor. And obviously we want to take care of that problem before we even think about doing anything with the catalytic converter. So my conclusion is, based on what we've done, we're looking at a faulty front O2 sensor. Steve, what do you think?
I think you're right. Basically what happens, we went right to Direct Hit. Direct Hit told us what to do to test the O2 sensor. It also told us to use a Volkswagen scan tool, an actual OE piece. But the Pegisys, which has all the OE test procedures, we performed that very first one, 034, in basic settings, and it told us that the O2 sensor was bad.
Absolutely, without that response.
Was smart. Yeah, it told us that. So then we went back, because we weren't 100% positive, maybe there's something else wrong. We went back to Global OBD2, still again with the power of the Pegisys, showing the milliamperage change of the O2 sensor, and it proved that it was bad.
Absolutely correct. So at this point, I think we're both in agreement. We got to get an O2 sensor in this thing. Okay, well that concludes our portion on our lovely little Volkswagen here. Next up's going to be Greg Montero, and Greg's going to talk about a Chrysler and some HVAC problems that that customer is having. Apparently he's got one that doesn't cool right, and it doesn't heat right. So that's what we're going to go ahead and do. Thanks so much.
Well, thanks, Jim. Today we're going to be exploring the customer symptom of poor air conditioning on a 2004 Chrysler Concorde. And the customer did mention when they dropped off the vehicle that in the summer months they're getting poor air conditioning, and wintertime, winter cooler months, lack of heat. So we're going to explore those symptoms today. Incidentally, on this system, the climate control is being controlled by the body control module. So I think what we're going to do today using the Pegisys is we're going to go ahead and check for diagnostic trouble codes in the body control module. So Steve, my assistant here, is going to do that. We're going to go ahead and access diagnostic trouble codes in the body control module. And it looks like we have no diagnostic trouble codes in the body control module. So let's go ahead and back out. We have another way to find a little bit more information that I want to show you today. We're going to go back to the main menu screen here, and we're going to click on the Diagnostic Information button. And then we're going to go to the Direct Hit Technician. And now what we're going to be doing is putting in a keyword of climate control. And we're going to see what pieces of information we can pull up from the Direct Hit Technician program. Now, as you can see, we have three different pieces here. We have the hotline archives, we have technical service bulletins, and we have Identifix articles. I think what we'll do in this case, we're going to feature a hotline archive. Let's go ahead and choose that. And yes, we got looks like a 2004 Chrysler Concorde. Let's go ahead and take a look at that one. Now I'm going to focus in first here on the top area where it says customer concern. And it says problems with the automatic climate control. After driving for about 15 miles, the heater does not blow as hot as it should, and the AC will not blow as cold as it should. Well, that's very similar to what symptoms we have from our customer on this particular vehicle. But let's go ahead and kind of dive into this particular archive and see what kind of steps we're going to do to diagnose this problem. Sure. It looks like our first step here is using a scan tool, retrieve any fault codes in the body control module. And of course, we've already done that step already, kind of knowing ahead of time that the BCM does control the climate control on this vehicle. So let's go down to step number 2, and it says record the codes, of course if you retrieved any, and remove the M1 fuse in the inside fuse box. We're going to record the trouble codes and remove the M1 fuse in the inside fuse box for 5 minutes. Now it is the one sticking up further than the rest in that particular fuse box. Now, the reason that we're actually doing this is that fuse actually is a battery supply power for the body control module. And what we're going to be doing here is we're actually forcing that body control module to do a recalibration on the climate control system once we reinstall the fuse. Okay, we've had the fuse out for 5 minutes. Now we're going to go ahead and reinstall the fuse, and then we're going to start the engine up. And remember what's going to happen here is the body computer is going to recalibrate the climate control system. And we're going to let this idle for 5 minutes. Well, 5 minutes have gone by now with the vehicle running. So I think what we're going to be doing is we're going to recheck the body computer for trouble codes. That is our next step. And Steve here is going to do that for me. So what has happened now, while we've had the car running, the body computer has been recalibrating the whole climate control system. We'll take a look here. Hey, we've got no diagnostic trouble codes. So how's our car doing at this point? We've done a recalibration on the climate control system.
Let me check.
Have it running with the air conditioning on.
Whoa, it's cold in there.
We got cold air? Good.
Oh.
Good. Well, that completes our segment on the Chrysler climate control system.
Let's recap for a moment. First, we checked diagnostic trouble codes. We didn't have any. So we really didn't have anything wrong electrically. So we went and did our next step, and that was to physically go to diagnostic information and then direct hit. Went directly to the internet to get repair information available to us without ever leaving the fender of the car. It basically ran us through a set of tests. It told us again to check diagnostic trouble codes, but it also told us to remove the M1 fuse. What that did was recalibrate the climate control module. Now, technically put, we had no fault codes, nothing electrical, so basically put, our doors were out of whack. The doors for opening and changing from heat to AC were basically telling us that, no performance, no heat, no AC at all. So we recalibrated the climate control module and the car runs perfect.
Well, we really appreciate you sticking around for these segments from the Direct Hit Technician.